I would like to show you a method for an ATA trap shooter of just exactly how to determine what your point of impact should be at a given target. And so we're starting out here with Trap American Fixed. That's the layout that we have. And I'm going to start out by deciding that I want to do this. I want to find out how far down the trajectory the target is when it arrives at 33 yards from the muzzle of my gun, and I'm shooting 16-yard targets. So I'm going to do this by going to Setup, then I'm going to come down to Edit or to ATA Trap Settings and click on that. And I'm going to go into the Trap Angle window right here and highlight that and put in a 0 and say OK. Now what I've done is I've told DryFire I want a straight ahead target coming out of the trap house. Next, I want to go ahead and pick out either a station 3 left or a station 3 right. It doesn't make any difference because 0 is straight ahead for both of these targets. So now I have on the screen exactly what I want. I'm standing on station number 3. I'm looking at the trap house and the target is going to be perfectly straight away from me. Now I want to find out how many hundredths of a second down this trajectory does it take before the clay arrives at 33 yards. And 33 yards for me is that magic point at which I want to get the shot off by 33 yards, because if I wait until after 33 yards, the density in my pattern will not be enough to break every target even though I point my gun perfectly. So that's what I'm looking to find out, is how many hundredths of a second is that. Now I'm going to use something called Target Tools, and if you're not familiar with this, come on over here to the left and you'll find Target Tools right here, the green bar. Left click on that and that will open up the Target Tools. Now there are several things in here that we can use. First of all, there is a target positioning bar right here, and if I click and start dragging this, notice down on the computer screen, here comes the clay out of the trap house. Notice in the lower left hand corner I've got a required lead box, and as I drag this target down its trajectory, it keeps recomputing what the perfect lead would be at that point down the trajectory. Now, the second thing that I can do is here in the time window, I can just simply come in here and highlight this and type in a time. Or if I know the distance down the trajectory in feet that I want, I can come to this window and put it in here. Now what I'm interested in again was how many hundredths of a second does it take to get to 33 yards. Now notice where I stopped it here. If I look down in the lower left, at 87 hundredths of a second, it was 34.46 yards. So I'm going to use that information and go up here then, and in the time window I'm going to put in, let's say, about 0.82. And now looking down here, 0.82 is 33.61 yards. I'm going to go ahead and guess again. I'm going to make this 0.79. And 0.79 is about as close as I can get. That's 33 yards. Now, notice here in the required lead, it says that I need the perfect aiming point is 8 inches above the target, or 8.1 inches. And that's based upon the gun that you say that you have in here at the moment. So let's go up here and click on the pencil to see what I have. And over on the left-hand side, notice over here, my point of impact I have set is at 33 yards. My gun is shooting perfectly flat, 0 inches. So with that, that is the way to determine how far the target will rise while your pellets are traveling from the muzzle of your gun to the clay. So believe it or not, even though that you think that the pellets get there in a mighty big hurry, the clay has elevated 8.1 inches while the pellets were in the air. So that means that if you pointed directly at the clay would be 8.1 inches above the center of your pattern. So this is what point of impact is all about, is trying to match your gun to what's really happening with the target. Now, let's get a little bit more precise, because what we've done to this point, this 8.1 isn't quite precise, so let me show you what we have to do to make it even more precise. We're going to go back up here to the pencil, and now I'm going to come in down here and type in the information it gave me at this point, 8.1 inches. I'm going to say OK, and then to get this box to recompute now based upon that new information, I have to come up here to the time window, highlight it, and put in 0.79. And when I do that, notice it says with this new point of impact that you have in your gun, which was 8.1 inches, you still are going to have to aim a half an inch higher because 8.1 was not quite enough. So that means I can come back up here to the pencil, click on it. I can then come down here to the distance above the aiming point, and I'm going to add a half an inch to that, make it 8.6. I'm going to say OK. And then in order to get this block to recompute, again, I've got to go back up here to the time window, highlight it, put in 0.79. And now notice that with a 8.6 point of impact at 33 yards on a straightaway on station number 3, I don't have to aim above the target or below the target. I could take a rifle and shoot it at that point if it was 1,200 feet per second, I might have mentioned. Okay, so now what we've learned at this point is that the trajectory at this point at 33 yards, the clay is going to rise 8.6 before my pellets get there. So that means that if I set the point of impact on my gun for that, I could do the following. Let me just kind of scroll in and get a little closer to this so I can use my pointer. Suppose now with this gun, which is set at 8.6, and let's say the tip of my arrow is the bead on the front of my gun, when that is right over the clay, if I pull the trigger, the pellets are going to arrive 8.6 inches higher in the sky, but the clay is going to climb 8.6 inches during that time, and I'm going to have a perfect vertical intersection. Now that's how you determine what the point of impact should be on your gun. Now the next thing I would like to do is I'd like to say, okay, how does this work on angular targets? Okay, so in order to do that, I'm going to go back to setup. I'm going to come down to ATA trap settings, and I'm going to type in the maximum angle, which is normal, 17.14, or if you can't remember that, just click the default button and it'll put it in there for you. And now I'm going to go up here and I'm going to select station 1 left. Okay, now I'm again going to go into the time window here and put 0.79, and notice down here it gives me all I need to know about hitting that hard left on station number 1. With my gun set to 8.6 inches as far as the POI, it says I need to shade it 0.2 of an inch lower, so it's almost identical to what I had on the straightaway, but I would have to be 1 foot 8.3 inches to the left of it. So let me come up here and let's zoom in on this target and let me show you what I mean by that. All right, now on the other target on the straightaway on station number 3, I said that my bead should be at exactly the same height as the target, which is right there, and it didn't need to be left or right because the target was flying straight away from me. Now on this target, the target is flying angularly to me, but it says over here in the vertical portion of the point that I need to be 0.2 of an inch lower, so maybe about this far. So if I bring my pointer straight out to the left, okay, so now what I'm showing you is the tip of that arrow is about a perfect lead right there. I'm saying that that represents 1 foot 8.3 inches to the left, and the tip of my arrowhead or the bead on your shotgun is exactly the same height as the clay in the sky. Because what's going to happen? From this tip right here, the shotgun pattern is going to be delivered 8.6 inches higher, which puts it right up here on the trajectory. And this clay during that time is going to travel down this trajectory, and it's also going to be at that same height. Okay, now let's take a look at this over on the right-hand side. I'm going to come up and change to station 5 right. And notice on station 5 right, I'm going to again go into the time window and put 0.79 of a second. Notice it gives me the same exact facts except that the horizontal lead is to the right of the target rather than to the left. You have to shade it by 0.2 of an inch lower, which since the clay is an inch thick, it's insignificant. You can basically say whatever you did for the straightaway target vertically, you did for the hard left vertically, and now for the hard right, you're going to do the same thing. Let's move in on that a little bit. And so what I'm saying is my bead is going to be at exactly the same height as the clay. The only difference is I'm going to be out here a certain distance to the right, and that distance I am to the right out here represents what I believe is 1 foot 8.3 inches to the right. So when I pull the trigger and my barrel is in this position, the pellets are delivered 8.6 inches higher, and the clay travels up the trajectory and arrives at that same point when my pellets get there. So that method of shooting ATA targets is what I call vertical elimination, because we've now developed a very solid plan about what to do with the verticalness. We make sure that our gun outdoors is shooting 8.6 inches above dead center at 33 yards. And then all we have to do is on a straightaway target, we bring the bead up until it's exactly the same height as the clay. And of course, in this case, it's going to cover the clay. But on every other target, whether it's going to the left or whether it's going to the right, the bead on your gun is always going to match the height of the clay in the sky. So now all of a sudden you've got a very simple rule in terms of solving all of your vertical problems, as long as your gun's point of impact is set to 8.6 inches. And that is irregardless of where the clay is in the sky, whether it's straight in front of you, as far to the left as it can be, as far to the right. It doesn't make any difference to you. All you do is you bring your bead up until the bead is exactly at the same height as the clay in the sky, and then you judge your horizontal lead to the left or your horizontal lead to the right, and that's all it takes. Now, I hope that helps you understand how I've arrived at this point of impact, and that is based upon what dry fire's mathematic has to show us. And I sure hope this helps you.